Okay. So as we count, we're going to start at 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 1, so on and so forth. Okay, incrementing in binary. When we get to 8, we're going to have a 1, 0, 0, 0. If we have a 1, 0, 0, 0, it's going to reset this here. Okay, so the count of 8, Q4 will be 1, Q3 will be 0, Q2 will be 0, Q1 will be 0. That's an 8. Okay, so if I have, remember the 4 LEDs that we have at the very upper right hand side of our board, the top LED is worth 8, followed by 4, 2, and 1, and this is A, this is B, this is C, and this is D. So at the count of 8, this light is on, and these 4 binary digits are going to go to our 47 decoder, and the 47 decoder is going to be wired to our 7-segment display. So if we enter a 1, 0, 0, 0, we're going to display an 8. Now, the next falling edge here, this Q1 will become a 1, right? It's going to toggle. We're in the toggle state. It's a 1. Well, now I have a 9. If I have a 9, well, first of all, it means that the 8 is on. Now the 1 is on. I have a 9. That's going to be sent to my decoder. And then I'm going to show a 9. What's going to happen on the next falling edge is this will go back to a 0. It'll toggle. And this bit here will be a 1. So now I have 1, 0, 1, 0. A 1, 0, 1, 0, which means that now my other LED is on. This one here, which gives us a 10. I don't want to see a 10. It's a mod 10. So what's going to happen? Well, look at my NAND gate here. It's tied to Q4 and Q2. So Q4 is a 1. Q2, if I follow it, is a 1. The output of an AND would be 1. Inverted is a 0. 0 is ground. If I ground the clears on all the chips, what's going to happen? It's going to clear all the Qs to a 0. And it's not going to go any further. You're back at 0, 0, 0. Now look what happens at 0, 0, 0. Well, Q4 is 0, so this is 0. Q2 is 0. This is 0. 0, 0, the output of an AND gate is 0, but it's a NAND, so it's inverted to a 1. So if it's inverted to a 1, all the clears are now hooked up to 5 volts, which is a logical 1. Which means what? Which means that it won't clear. It's going to count normally. So if I have 5 volts on clears, it's going to continue to count. Now, if we start incrementing the count, well, if I have a 1, Q1 is 1, followed by 0, 1, when Q2 is 1. Well, let's try that. What happens at the count of 2? At the count of 2, I have 1, 0. Well, 1, 0 will give us a 0 inverted as a 1. It'll continue to count. I'm not clearing yet. Only when 8 and 2, which equals to 10, will I get a value of 1 and 1 here, which will give me a 0 on the clears. And that's how it clears and counts only 10 digits. I have to start with the truth table. I want to count till 10. So at 10, I put a 1. Anything above that on the truth table is a 0, like we had written down here. Anything above the truth table is a 0. Anything below it is an X. We're building a mod 10, so mod 10 is a 1. We want to extract a simplified equation, so we plot it into the Karnaugh. We make the largest group possible with a 1, and any x, we need to make it a bigger group. We extract Q4 times Q2, which tells you that you're tapping off of Q4 and Q2, and you're ANDing them together. And again, why is it a NAND then? It's a NAND because we're using a negative logic JK, which is the 76, where we need a 0 to clear. So we're going to use a NAND to take that 1, 1 and convert to 0. And that 0 will basically clear all these gates. And that's how it's going to count.